All right, here we go with problem 5. 5. An object moves according to the graph to the right. Part A, the only part, what is the velocity of the object at the 1.5 second mark? All right, when a lot of people see a graph, they think velocity is slope. But this is a velocity graph, right? It's not showing position, it's showing your velocity already. So if they ask you what is the velocity at the 1.5 second mark, on your time axis, you want to go over to where 1.5 would be. So right between 1 and 2, halfway, would be 1.5. Go straight up here and see that right there, that's where your velocity is. So on that axis, on my velocity axis, between 2 and 4, that's 3. So that's your answer. You don't need to find slope. On a velocity graph, the velocity is already shown. So D is your answer on that one. Okay, problem 6. Jasmine starts at a speed of 0 and speeds up to a positive velocity. Part A, draw a motion diagram to show that. Alright, this one is probably the most simple one on the test because you guys have done a lot of motion diagrams, and this is the most standard one to do. So every motion diagram needs an axis. So draw your axis. On that axis, label 0 and label it X. That's already a point. Okay, next step, we need to make our dots. So it starts at a position of 0 and it speeds up in the positive direction. So they start close together. As time goes on, they get further apart. Our velocity arrows will connect those. So our velocity, we're going to make it be moving in the positive direction. Connecting these dots with arrows. Our arrows are getting longer because the object is speeding up. And the other part are acceleration arrows. The rule is if it's speeding up, acceleration is the same direction as the velocity. So these little arrows are also pointed in a positive direction. Great. That's your motion diagram. Okay, so now to make graphs that match that motion. Draw a qualitative. Qualitative means no numbers. So draw a qualitative position versus time and velocity versus time to show the motion. So since there's no labels on these graphs, that's the first thing I want to do is label the axes. So this is going to be my position graph. I want to label this axis position and this axis time. It didn't tell me what things are measured in, so I actually don't need units, but I do need to know what the axes are. This one over here would be my velocity graph, velocity versus time. All right, next step. We showed it on our motion diagram starting at a position of 0. It starts off slow. It starts off with a speed of 0. So that means this slope on our position graph needs to start off flat. As time goes on, though, it speeds up. So as time goes on, it curves upwards. Maybe not that much curve. Let me redo that one. But it starts flat and it slopes upward. It gets steeper and steeper. That's showing something speeding up in the positive direction. Now on a velocity graph, what that would look like, if it starts with the speed of 0, starting off flat, it's speeding up in a positive direction. So to show that, we're going to have a straight line that's sloped upward. Okay, so it's sloped up from that speed of 0, sloped upward in a positive direction. It's a straight line getting faster and faster as time goes on. All of this motion diagram, this position graph, this velocity graph, they all match now.